The next two topics that we're going to address are both exponents, which also known as powers, and square roots. So we're going to look at exponents and square roots. So an exponent in its general format is known as a power. A power is an expression written with an exponent and a base. So as you can see, I've given the example of 4 to the power of 5. The number 4 is known as a base. That's the number that's going to get multiplied. The 5 is the exponent. The exponent is how many times you're going to multiply that base. So 4 to the 5th power is the same thing as 4 times 4 times 4 times 4 times 4, which is 1,024. Now, the most common mistake that's made with exponents is that many students confuse that with just multiplying those two values. So 4 to the 5th power does not mean 4 times 5. That is not what that means. 4 to the 5th power means take the 4 and multiply it 5 times, not take 4 and multiply times 5. So it's a very easy mistake. So take time to correct it. So let's do a few examples with exponents. First off, 8 to the 1st power. Anytime you have anything raised in the 1st power, it's just that number. So 8 to the 1st power is 8. Negative 2 raised to the 3rd power. So negative 2 raised to the 3rd power is negative 2 times negative 2 times negative 2. And then you work out the problem. Negative 2 times negative 2 is positive 4. 4 times negative 2 gives you negative 8. So, part C. You have 2/3 squared. So, a hint for you. If you have a fraction raised to an exponent, give the exponent to the numerator and denominator. Then solve it. So 2 to the 3rd power is really 2 squared divided by 3 squared. 2 to the 2nd power is 4. 3 to the 2nd power is 9. And you're done with the problem. You're done with it. Lastly, you have minus 3 to the 4th power. So this is a little tricky, so you have to pay attention to how it's set up. Notice that the minus sign is not inside parentheses. That's important. This minus sign is not inside parentheses, so what you would do is you would bring it straight down. Bring the minus sign straight down, and then work out 3 to the 4th power. 3 to the 4th power is 3 times 3 times 3 times 3, which is 81. So your final answer would be negative 81. So notice it's a big difference. If this was negative 3 raised to the 4th power, then it would have been written like problem B was written. If it was negative 3 to the 4th power, it would have been written as negative 3 in parentheses raised to the 4th power. But since that's not how it was written, this is how you would solve it. So again, it's subtle, so you just have to pay attention to what you're doing. Notice that I have a need to know box for you. You should, at this particular point, know the first 12 what's known as perfect squares. So if you don't know them, take the time and actually learn them and commit them to memory. But 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. So that's the first 12 perfect squares. If you're able to recall those very quickly, then it makes your solving a lot easier as you go on down the road. But let's switch gears to the square root. So a square root of a number n is the value that when multiplied times itself will give you that number n. So here's what that means. You have the square root of 100. That means n is equal to 100. N is equal to 100. So you're looking for what number times itself, it has to be the same number, will give you 100. In this case, that number is 10. 10 times 10 gives you 100. So the square root of 100 is equal to 10. Square root of 100 is equal to 10. Now, you don't have to write this all out every single time you're taking a square root. You can just go ahead and do it. I'm writing it out so that you can see the thought process. However, there is a common mistake that is made with square roots. Most people confuse square roots with dividing by 2. That is 100% not true. False. The square root of 100 does not mean do 100 divided by 2. So that's an absolute no. An absolute no. Square root does not mean divide by 2. Square root means figure out what times itself will give you that number. So with that being said, let's do some examples. So for A, we have the square root of 81. So that's asking you what number times itself is going to give you 81. And in this case, that's 9. 9 times 9 gives you 81. Part B, minus the square root of 16. Notice where that negative is located. It is outside the square root. Since it's outside the square root, simply bring it down. The square root of 16, what times itself gives you 16? That's 4. So your answer is negative 4. Problem C. If you're taking the square root of a fraction, take the square root of the numerator and denominator, and then work it out. So again, there's that negative sign sitting out in front. Bring it down. Then take the square root of 169, divide it by the square root of 9. The square root of 169 is 13. The square root of 9 is 3. So your answer is negative 13 over 3. Lastly, with part D, if the square root is not a perfect square, then use a calculator to find the approximate value. So in this case, there is no number times itself that will give you 29. So then you would just use the calculator to calculate it out. So that gives you 5.3851, and it goes on forever in a calculator. Your teacher will tell you where you would need to round. Later on, you'll learn how to simplify these type of expressions because you're not going to be allowed to give a decimal answer all the time. But in terms of your need to knows, just like you need to know the first 12 perfect squares, you need to know the first 12 perfect square roots. The good part is, if you know the first 12 perfect squares, you already know the square roots as well. Square root of 1, 1. Square root of 4, 2. Square root of 9, 3. 4, 5, 6, 7, 8, 9, 10, 11, and 12. So if you got to know it one way, you also know it the other way too. So that's a brief look at exponents and square roots.